Hello everyone! In this video we are going into the formulas for straight lines. We will first have a look at some things called the gradient and the y-intercept. Then we will have a look at where they appear in the formula. And then we will have a specific look at rising, falling, horizontal lines, and lastly vertical lines. Since there's a lot of information going on in this video, I will end with a summary. Also, since it has many parts, make sure to use the timestamps in the description to go to the part you want if you are not interested in the full video. So let's start with that gradient and y-intercept, and I'm going to go back to that table I used in the last video. That table, like all tables, has a graph, and we already said something about a starting value last video, the value where the graph starts, where x is 0. So in that case, that is 7. We call this number the y-intercept because it is the point where it intersects the y-axis. Then we had another important point, and that was the step. That was what made it a linear relation. And this step, we call that the gradient. It essentially tells us the step, or in the graph, how steep our graph is. So these are the two elements that we are going to need to make a linear formula, to make a formula for a straight line. You could think of the y-intercept as telling us the place of our graph, where our graph is, and then the gradient tells us the direction or the slope of our graph. So let's see how this actually works in a formula. And again, I'm going to use the formula from the last video, where we saw already that at t is 0, we could calculate that a equals 20. So that 20 was the starting value. And I also mentioned that 40 was the step, because, well, if t is 3, then we do 3 times 40. But if t is 4, we do 4 times 40, we add another 40, etc. So 40 is the step, is what we add every time t becomes larger. So that means that this starting value, the number we start with, that is actually our y-intercept. And what we increase per step, that is our gradient. Let's translate this to a general formula. The general formula for a line looks like this: y equals ax plus b, where we just use x and y as variables. So in here, b is the y-intercept. It's the number that is left even if x is 0, so the entire ax disappears. And that leaves a as the gradient, the number that we multiply by x. So that is added as many times as we have x. That is added every time. Using these two parts and filling it into the formula, we can make a formula for any straight line. Now let's think about what happens with graphs that go in different directions, like these three. I'm already saying direction, so that has to do with the gradient. The y-intercept doesn't tell us what direction it goes, doesn't tell us whether it's rising or falling. Now if the gradient is larger than 0, then clearly we are adding something every step of the way. So our graph must go up, must be rising. So in this case, that would be for the green line. Conversely, if our gradient is smaller than 0, maybe -5, then we are subtracting something every step. So our graph goes down, it is a falling line. So that would be the blue line. So we've had positive gradients, negative gradients. That leaves a gradient of exactly 0. Then we're not adding anything, not subtracting anything, it just stays the same. It's a constant line, it's a horizontal line. And in this case, it actually does something interesting for the formula. Because, well, I could fill in 0 for my gradient like this, 0x plus 16, but 0x is just 0. We don't have to write that down. So we won't actually see an x in this formula. It will just be y equals 16. And that actually makes sense because no matter what x is, y is 16 everywhere on the graph. So y is 16 perfectly describes this line. Now for the three graphs on the right here, these are the three formulas. So for the line that goes up, the rising line, we have a positive gradient. It goes 3 up every step of the way. For the falling line, we have -2 as a gradient. It goes 2 down every step of the way. And then, of course, we have that y equals 16, where it's just a horizontal line. So it's great to have horizontal lines, but what about vertical lines then? Here we see a green vertical line, and if we think about it, it doesn't cross the y-axis, so there's no y-intercept. It doesn't go, it goes infinitely up, but there's not really a gradient. So there must be something different here. Now we saw that the horizontal line in this case was y equals 16. So if horizontal is y equals 16, then maybe vertical is x equals something. And actually, well, here x is 4, but here x is also 4, here x is 4. Along this entire line, x equals 4. And that is actually the formula for this line. More generally, any vertical line will be x equals something, and any horizontal line, y equals something. But keep in mind, this is the only type of line that will look like x equals something. Everything else will start with y equals. So this is a very special type. All right, that was a lot of information, so let's summarize, and let's start by summarizing that y-intercept and that gradient. And we'll go through the three different ways we can look at that. So in the formula, an example here, the y-intercept is the number that is added or maybe subtracted at the end. Keep in mind, if it's subtracted, the minus is part of the y-intercept. And the gradient, that's the number that's x or a or q, whatever variable you have, but that the variable is multiplied with, so in this case 3. Again, it can be positive or negative. Then let's have a look in the table. In the table, if we want to know the y-intercept, we look at the value of y at x equals 0. And for the gradient, we have a look what happens if the top row increases 1, if the top row goes 1 up, what happens to the bottom row? That is our gradient, what we add or subtract there. Then last but not least, in a graph, the y-intercept is the height where the graph intersects the y-axis. And our gradient is the answer to 1 step to the right is how much up? Again, this can also be negative. Then you go -5 up, which means 5 down, but then -5 would be the gradient. So that's a summary for y-intercept and gradients. Let's quickly have a look at the different directions we had as well. We saw for a rising graph that our gradient had to be larger than 0, so we added stuff. That for a falling graph, the gradient had to be smaller than 0, so we were subtracting something. And then we had a horizontal graph that was y equals something, because the gradient is 0. And for a vertical graph, we had a very special case where x equals some number, and where there is literally no gradient and no y-intercepts. So that is all I have to say for now about formulas for straight lines. I hope this helped you be able to find the y-intercept and gradient of a linear formula, and that you now know how to tell from a formula whether its graph is a rising, falling, or horizontal line.